Okay, this is integration packet number 9, and I'm looking at problem 5. I've added in details to the diagram that I'm given. Establish that the line, the equation of this part of our curve is y equals x minus 3. And I have identified where 3 is, and that this is a value of 2. So x equals 3, it has a value of 2. So since we are dealing with the accumulation function, all right, the derivative of the accumulation function, so the derivative of at 3 of h of x is the value of the curve. So this is simply 2. Now B gets into looking at the little bit of area past 7, so 7.5. This is 5 right here, 6, that's 7, and 7.5 would go down here. So once again, we'd have one of those trapezoids that we would need to find the area. The value of h of 7.5 is the value of h of 7 plus some value, and I'm going to call it c. So we have to get up to 7.5. So here you can just calculate, you can add up the squares, and you're going to find that the area of h of 7 is 16. So I have to find that plus that c part though. So c is the area of a trapezoid. So it's a half times the sum of the bases. Now the sum of the bases, we have at 7, since our function is y equals x minus 3 at 7, we'd have a height of 4. And at 7.5, we'd have 4.5. And then we have to multiply it by our base, which is this little red spot that I'm showing. And that space is just a half as well. If you compute that out, I believe that C comes out to 2.125. So our value of h of 7.5 would be 18.125. Okay? Now the number up here says we're going to take h of 7.5, which I just established is 18.125, minus h of 7, which you can figure out is 16, and we're going to all divide that by 0.5. And if I have done that correctly, I believe it's 4.25. Okay, for C, the idea is the same as what we just did in B, but instead of having specific numbers, we're just going to go from 7 to 7 plus h. So our delta x is just the value of h, whatever that is. So in order to find out what h of 7 plus h is, that's the value of h at 7 plus a little bit more. And in this case, I'll call it a little bit more d. Okay, so our d is the area of this rectangle, and the area of the rectangle, of the trapezoid, the area of the trapezoid is half the sum of the bases. Okay, the sum of the bases, well, we know that at 7, we know that value is 4. Okay, and then at the right-hand side of the trapezoid, well, I have to put 7 plus h into my function. So I have 7 plus h minus 3. Now I have to take and I have to multiply that by the base, which again, our base is just h. So if I do some computation here, we have the half. The 4 plus 7 is 11, minus 3 is going to be 8. So 8 plus h times h. And then I'd have 4 plus a half h squared. Now that is just d. So h of 7 plus h is h of 7, and h of 7 is, and h of 7 is 16. And then I have to have what d is. And you know what, I'm looking at this again. D really should be 4h plus 1/2 h squared. So I have, so h of 7 plus h now we need to take the limit as h goes to 0 of h of 7 plus h minus h of 7 all divided by h. Well, if you do that, we just established that h of 7 plus h is this factor right here, and h of 7 is 16. So if I do that, I'm going to be left with the limit. If I do that subtraction, I'm going to be left with the limit as h approaches 0 of 4h plus 1/2 h squared, all divided by h. And if you take that limit in the first term, the h, and do the division, you're going to have just 4. And you're going to have 1/2 h if you do the division on the second two terms. So the limit at that whole term is just going to go to 4. Now let's take a look at, up here. We're trying to find the derivative at 7. So my value on my x-axis is 7. And take a look. My value on y is 4. So now, again, this h of x is an accumulation function. We're adding up all the rectangles underneath the curve. And then, down here, I'll find the derivative of the accumulation function. Again, this is the derivative of the accumulation function. Perhaps these two ideas aren't connecting yet, but integrals and derivatives are inverse functions of one another, so it's important to get that idea down.